class we did study about some of the basic functions of a decoder. This class we would be studying about how to implement a particular function that is given to us using a decoder. Okay, so we are given two functions. That is a sum is 1247, the summation of 1247 mean terms, and a carry would be there, that is the summation of 3567. This is essentially a full adder operation. Okay, so you can say that we're going to implement a full adder using a decoder. So this is the particular truth table for that. This one is the truth input side and this one would be the output side. The procedure is very simple. As you have three inputs, so the decoder that we are going to use it 3 by 8 decoder naturally. So this is the figure for that. Now what you have to do is, for whichever mean term configuration the output is 1, you have to combine them together to form in the OR gate, and you have to form the particular output. That is for the sum. If you are going to consider the sum, we see that for D1, D2, D4 and D7 your sum is defined, or the function, you can see that the function is defined. So what you have to do is to naturally just add them all together using an OR gate, and you will get the respective function implemented at the output. Okay, you just have to connect the respective outputs to this particular OR gate. In the same format for the carry operation, you see D3, D5, D6 and D7, just exactly that we are given in the carry expression. You have to do the very same thing and you will find the carry output here. So this 3 is going to be your input, whereas sum and carry is going to be your output, and you implemented all this using a simple decoder because this is a ready to available package. So you can implement function using this. No need to design any complicated circuit for this. Okay, so next we're going to study about the inverse of a decoder, that is an encoder. Now this one is pretty simple. It contains 2 to the power n input, whereas the output would be of n bits. Just the inverse of a decoder. Now input, we're going to consider that as only one input is active or high at a single time, whereas others are going to be your 0. For an encoder, not all of the inputs are active at the same time, or multiple inputs are active at the same time. Only one input is active at the same time. Now depending on whichever input is activated, your output is changed accordingly. If your D0 input is activated, then the output all are going to be low or 0 0 0. If D7 input is activated, then the output all are going to be high, and that is defined by its respective mean term. Okay, now how to define all this x, y, z? You just have to add your respective input here, just you do in the case of case of finding a function. The x is going to be your D4, D0, D1, D2, D3, D4, D5, D6 and D7. For whichever input your output is defined, you just have to add them together and you will find the respective function for that. So this is the defined procedure for finding the output expression of an encoder. Okay, now this is the basic diagram for this. 2 to the power n by n encoder, which has 2 to the power n input and n output, and for this particular configuration we're going to have 8 inputs and accordingly 3 outputs. So that would be an 8 by 3 encoder. Okay,